people are kind of trying to optimize around the chunking strategy and should I be chunking with a JSON representation or with a markdown representation or plain text, right? I see a lot of discussion there. But for me, like that seems a bit maybe not focusing on the right area of optimization. These embedding models themselves have gotten just like so much more advanced over the past 5 to 10 years that regardless of what representation you're passing in, they do a pretty good job of being able to understand that information semantically and returning the relevant chunks. So I definitely would love to maybe see a bit more attention shift to like, hey, like how do we continue to kind of drive innovation on the embedding model so that in the next 5 years, next 10 years, we're still seeing these leap in advancements that we have in these embedding models that we have seen in the past 10. And I think the juice is probably more worth the squeeze there than figuring out like different ways of chunking the document that gets embedded.
Hey buddy, welcome back to another episode of How AI is Built. Today we have a very special guest. Derek Tu is the founder and CEO of Carbon. Carbon is an ETL tool specifically built for LLMs. It connects you to your clients, Slack, email, Google Docs, and parses and chunks all the unstructured data before it delivers it to your vector database. You can learn how you can normalize unstructured data, build AI pipelines, and how Carbon approaches common issues in data integration.
We were basically doing a lot of like AI agency work. This was before ChatGPT came out. So we were already doing a bit of like agency work, consulting work, contract work. And then we started after ChatGPT launched building our own consumer Gen AI applications. And one of them that got really popular was a no-code AI app builder. And then we basically were one of the first to integrate Google's Palm 2 API, which is their predecessor to Gemini. And then we got featured actually at the Google keynote last year. And that basically gave us a huge influx of users. And all of these users were asking us for kind of one thing very consistently, which was to be able to, connect external data sources. And then from that, we started kind of building it out. We started out using open source solutions first. It kept breaking. The integrations were quite shallow, not what we wanted, especially for that RAG use case. So at some point, we're like, hey, like we want this to be a core competency. We started building it in-house. Then we started talking to other AI founders who also had a similar problem with ingestion from different data sources. And then basically, we started to open up what we built as an API to the other founders. And then we found really strong usage. We found kind of really strong market pull from our initial pilot customers. And that was really what gave us the conviction to pause everything else and focus solely on Carbon moving forward.
Yeah, and what was the evolution like? Because especially when I'm looking at your docs, it seems like you really started out focused on file storage, like Google Drive, OneDrive box, like more of the content side, and now you're moving into like email, Slack, and stuff as well.
Yeah, so we look for opportunities where there are a lot of unstructured data because the magnitude of unstructured data being created out there is like 10x the magnitude of structured data. But if you look at kind of like the incumbent like ETL providers, the iPaaS vendors, they mainly focus on structured data, right? Giving you a unified API to grab the JSON responses from different endpoints in a unified manner. We're loading your kind of ad spend data from AdWords into Google BigQuery, right? What we really focus on is unstructured data primarily. So conceptually, we go a level deeper than just the API response that you get back. So of course, it made sense to kind of start, and this is kind of where customers also really guided our roadmap. The first step was, hey, like they wanted to upload files not only locally but from different cloud storage solutions as well, right? SharePoint, OneDrive, Google Drive, etc. And then quickly, like they were looking to expand, and we're also looking to kind of add more connectors and saw a pull on the customer support side. Like a lot of these customers were building CX agents, CX chatbots, and they wanted to pull in their customer data from Intercom, Zendesk, Salesforce, etc. So that's kind of our second pocket of integrations that we tackled. And then we started seeing a lot more AI employees, AI agents that could help with more like generalized tasks, like maybe pulling in emails and responding to Slack. So that's when we decided to focus on things like Notion, Confluence, Slack, Gmail, Outlook, etc. Right? So the launch of these connectors went hand in hand with the customers that we were onboarding at that time and where in the market they were looking to build out their niche and their go-to-market motion.
Yeah. And do you see the customer progressing through Carbon like that as well? Basically starting out with something like chat over your documents and then moving more into like CX and complete agents?
What we are seeing is, at least in the new customers we are onboarding, initially it was like chat with your document, and then it became chatbots. Then it became like co-pilots, and now it's agents. So the type of customers that we're bringing in the door almost kind of map directly to this kind of AI hype cycle we're seeing and what is super sexy at a certain kind of stage in this cycle we're going through. We are seeing kind of the earlier customers start branching out from chat with document and chatbot to agents, right? That could take action and maybe using multiple LLMs in tandem for reasoning. But I'd say like a lot of the early customers we onboarded did find product market fit with a specific niche or a specific pain point. So we're seeing maybe less pivoting than we initially thought like our customers would do. It's more so kind of expanding from like one ICP into another. So maybe they were doing CX, but now they're also doing CX and sales enablement. And now they're pushing us to add like sales enablement connectors as well. We're definitely seeing more of that than people going like, hey, like I started out with like chatting with documents and now I'm building an agent. Not sure if that's kind of reflective of the kind of broader market as a whole, but definitely something that we have observed on our side.
And what's the main target group in terms of the customer who are implementing this stuff? Are you targeting more software engineers or the new group of AI engineers or data engineers?
I think it's all the above, right? Because I think like the title for someone who is building out these workflows with LLMs isn't fully baked yet. Like depending on the org, depending on the company, that could be an AI engineer, it could be a ML engineer, it could be a data engineer, it could just be like a full stack engineer. I think kind of this particular cycle apart is everyone could be an AI engineer now, just because of how much kind of OpenAI and these other model builders and hyperscalers have democratized access to these LLMs, and the barrier for being able to build an LLM powered product has significantly decreased. So, we're seeing founders from all different previous experiences and industries come and build these AI products. And we're definitely riding the tailwind of that is, when you're coming to build an AI product, you probably don't want to build out like this ingestion pipeline that we can manage on your behalf, right? They have so many other kind of moving pieces that they're trying to figure out, experiment with, productionize, that they really kind of want to leave the heavy lifting on the data side to someone like Carbon.
Yeah. And how would you actually say it differs from the existing data engineering tool stack for data ingestion? I think there are a bunch of new tools coming up like DLT, but you also have like the older ones like Airbyte by now.
Yeah, for sure, for sure. We get that question a lot. I'd say like the main differentiator for these like legacy ETL tools, they are about data movement internally across your organization. They want to move ad spend data from Facebook and from Google AdWords, right? They want to standardize, normalize, transform that, and then sync it over to your data warehouse, whether it's BigQuery or Snowflake. For us, what we really focus on is allowing our customers to get access to their end user or their customers' data. So that use case is a multi-tenant use case where the users of Carbon really sits outside of the company and the organization, and they're trying to sync content to provide our customers access to that content, right? So in a vein, it's very similar to what Plaid did for fintech. Plaid allowed any fintech company to easily connect to their users' bank accounts. We're really doing the same thing for different sources of unstructured data. So these LLMs that our customers are leveraging to build out these AI-driven workflows has access to internal or external data from their end users that they're able to leverage.
As far as you can talk about it, what are some of the most interesting use cases you've actually seen in that vein where basically your customer connects to other people's data sources?
Yeah, I mean, we have a lot of potential use cases just given that we're such a horizontal product offering, right? A few kind of customer use cases I definitely would love to call out. One is there's this company that is using us for semantic autocomplete. So users can upload a bunch of their research papers via Carbon, and then we basically help with that writer generate the next sentence or the next paragraph based upon the contents that they want to cite and use as part of that research paper. So we thought that was really cool. It was a very kind of interesting exercise getting the latency down to a point where it's almost kind of near time. So as the user is typing, we could, within a couple milliseconds, suggest what the next sentence is and then what the next paragraph can be. Right. So that was really cool. We definitely have a few like AI employee, AI clone, AI agent companies that I think are doing a lot of incredible things. Even though there's like a lot, I say their kind of use case and how they're building out the workflow definitely makes each one different. So we have one that is more tailored towards private equity, VC deal rooms that I think is really, really cool. We have another one that's building kind of like a next generation Zapier where they're using Carbon as like knowledge hub for each of the agents. And then those agents could then go ahead and take actions in other systems as well. So that's really cool. We also see use cases emerging around enterprise knowledge search. So a lot of people, they want to be able to search across documents and data across their team and across their company. They're using kind of Carbon to build out the infrastructure for that sort of knowledge search. And that's something that we're seeing kind of emerge as larger enterprises are adopting generative AI as well.
Since you're connecting to many different data sources, how do you actually handle the different like idiomatic data representations in, for example, like Google Drive, Slack, and how do you bring them like on a normalized level so you can process them in the same manner?
I think that's kind of the hardest piece, right? I think that's something that engineers who might not have that data background, they tend to trivialize. So they're like, oh yeah, like that's fine. Like I can handle that myself. And they realize, yeah, like, I don't want to do that normalization. It is hard. And I think it's something that we spend like the most time on. And that's kind of why we started out with like cloud storage, right? Because documents, like they're quite normalized already. Emails, Slack messages, tickets, those are things that I think we have done a lot of kind of fine tuning around the normalization there. I would say kind of what we try to persist during that normalization is the rich metadata of who sent what and when it was sent, what channel or what thread it was sent in. So we do kind of a lot of that like metadata injection into the content as well, so that we really kind of persist those relationships too. At the end of the day, I'd say it's still more of an art than a science. We work really closely with customers to see, hey, like what sort of chunking strategies, what sort of parsing methods yield the best results. And we really kind of learn from them as well, from the experimentation that they might be doing outside of Carbon. And it's a very collaborative process as we try to implement novel techniques, especially for this kind of RAG architecture. They're able to yield the best results without really taking a hit to performance and search latency.
I'm really curious, do you treat documents and chats internally with different data models, or do you basically enforce one internal representations and you bring both into this?
They're different representations under the hood, but we provide a unified API for retrieving data across all of the sources. So even if the user syncs email and then they sync a document from Google Drive and then sync conversation from the Slack channel, they're able to search across all of them. But underneath the hood, the way we process the data and how we store the content is different.
Yeah, I'm really curious. What is the difference? Because I've never worked on RAG on like chat like messages or Slack threads before. What's the main difference to regular documents?
That's a great question. I would say like it's the fact that these conversations, even these email threads, could be very, very, very long. Because if you ever come back and forth with a client or a vendor or even someone internally, like in the email or like a Slack thread, it could be like hundreds of messages. So it's finding a way to how do you chunk that? How do you make sure that who sent each message, when they sent it, who they adjust it to, right? Because even on like email, like people get CC'd and people get removed all the time. Similar with like tickets. If an agent starts a ticket and then hands it off to another, how do you know that handoff happened? And how do you know like if they're addressing the same person or if that person CC'd someone else on the ticket as well, right? So the actual content is important, yes, but there's just a lot more like rich metadata around that content that needs to be represented as well. And I think that's kind of where most of kind of our job comes in. It's like, sure, like we could parse like an email, but then how do we provide the email and its accompanying metadata back to the user so they could imbue all of that into the context window of the LLM that they're using to generate a response or take some sort of action based upon the context.
And do you actually perform some basically pre-filtering when you're doing a retrieval on documents on Slack messages? Do you pre-filter for certain threads, basically like an HNSW index where you first go to a thread and then search within the thread?
Yeah, so that's how ticketing emails and Slack work. We don't want to pull in everything from both like a cost perspective and also then you're just like introducing a lot of like potentially irrelevant information. So we always have the users set pre-filters and then we sync based upon those pre-filters. Once that content sits in Carbon, you could add additional filters to search by to narrow down the search space when you try to request or search for a chunk or when you pass in an embedding. So I think filtering is very critical, both in the actual like syncing of the data and then the retrieval of the data from Carbon.
Yeah. And I think like especially the Jason Liu from Unstructured has like some interesting blog posts on that when he's doing some query pre-processing and extracting like date time ranges from the user's query, which is really interesting.
Yeah, and I think like that's the other thing about these kind of tickets and emails, right? Is that there is a time variable as well that is not present in a document. A document, you just really care about when it was last updated or when it was created. With messages, like you really care about when something was sent because even the sequence of when it was sent really impacts the semantic understanding of that thread. So there's just a lot more vectors that you, no pun intended, that you need to think about when you're processing and enabling retrieval of these kind of longer threads, emails, tickets, etc.
Yeah. And I think in RAG, for me, especially when you're treating vector databases, it's a little bit underexplored how to actually clean it. And I mean clean on like different levels. For one, cleaning the vector database from irrelevant content which is never used, but also cleaning out the documents. Do you actually clean out the database over time, especially when you're looking at messages that you treat some chunks with an expiration date?
Yeah, this is a great question. So we don't like touch or tamper with that data because it's our customers' data, right? It's like their end users are syncing that data. So we don't like go through the messages and delete things that we think is irrelevant because they might think is relevant, right? With that being said, like we allow our customers to append tags to the files and to the content that their users are uploading. So they could always kind of use that as a way to narrow down the search, filter out irrelevant data. We definitely see like a lot of them do that. I think the more sophisticated ones could be putting the documents that are uploaded through an LLM and then doing some auto tagging and then appending those tags to Carbon so that when a user is trying to retrieve data, they could always filter by those tags before retrieving the relevant chunks to pass into the context window.
Yeah, what are some tags you have seen that work particularly well?
Yeah, I think across the board, tags that we have seen be like really, really kind of strong are, for example, if you building multiple agents for a user, you might want to pass in like an agent ID for each subset of files that were meant to be retrieved or accessed by that agent. Something very small, but it really kind of, if a user is uploading their entire Google Drive, they probably don't intend for an agent to have access to all the documents in that drive. So doing that sort of like tagging beforehand, we see yield very successful results. Others are like topics. Maybe they're uploading a bunch of files. Maybe some are like product docs. Others are sales document. But an LLM can easily kind of just read that and be like, oh, hey, like I know this is a sales doc. This is a product doc. And maybe they're passing in like a set of departments or categories they want the LLM to go in and tag each document with. So that's another kind of very effective way as well, because then maybe as the human user, is having a conversation with an AI employee, they know that human is in the product department or the sales department, and they know to retrieve any content that is related to topics that that user might be interested in.
Yeah. And moving down a level towards the chunks, how do you actually approach the chunking strategies?
Yeah, so in terms of chunking strategies, we basically allow our customers to customize that. Again, because we're very horizontal, we really kind of see a lot of different use cases across different industries. We really care about giving our customers that flexibility to experiment and to implement whatever works the best for them. So kind of our ethos is we really think ourselves as like an end-to-end, like RAG as a service provider. We think ourselves as more of a utility provider where we give our customers access to different utilities that they could opt to leverage. So, for example, we have data connectors, but where this data from these data connectors flow is up to them. So they could just take the files that we share with them, like we give them access to from their users, and they could do all of the parsing, chunking, embedding generation, vector storage on their side, or they could opt to use different utilities we provide them as well. So we have a utility for handling chunking and embedding generation. We do have support for table parsing and OCR. But at any given point, they could say, okay, now I want to bring this data into my system, and they could retrieve those plain text from our parsers, or they could retrieve the chunks and embeddings for us and store it in their vector storage. So we give them a lot of optionality around how they actually want to take the data we provide them and bring it into their in-house RAG pipeline.
What are some of the best working chunking strategies you have used or seen used?
I think it's all like very like use case and document specific, right? I would say like honestly for maybe 80% of cases, like normal token, like splitting on token and then chunking based on tokens works perfectly fine. For that extra like 10 or 20% performance boost, maybe you could look at semantic chunking, but that's expensive. Another thing we do is for tables, we chunk that basically as a CSV file. It also then varies depending on the data format and structure within those documents as well. In my opinion, we're still very much in the early innings of figuring out how to chunk or how to run retrieval. So I think we're still seeing our customers and ourselves doing a lot of preliminary experimentation, but it's, I think, hard to tell at this stage what the standard is or if there will ever be a standard way to do this chunking and embedding generation before the content can be indexed and retrieved.
Yeah. And in your experience, I think it's very interesting to always see like what your personal preferences are in the tools you actually choose for your own implementations. What is like more of the decision matrix when you look at different vector stores? Because that's a major area of discussion right now.
Yeah, so again, we love giving our customers options. So we don't lock them into using one vector store or another. We basically allow customers to bring any vector store that they want, whether it's quadrant or pinecone or PG vector, right? We're very agnostic to that. As long as that storage solution could store vectors and then enable some sort of retrieval on top of the vectors and chunks that they're storing, that's totally fine for us. Now, kind of underneath the hood, we actually have a vector store where we offer the serverless vector search, if you will. For that, we opted to use Quadrant. We're very early adopters of Quadrant. We basically found them when they only had an open source solution, and I think we were one of the first that used their cloud solution when they launched that a couple of years ago. So, we've been with them ever since. I do think they do a really great job with cost optimization and just overall performance. I believe they were probably one of the first to introduce binary quantization. And then one thing we discovered is when you're implementing hybrid search, a lot of these other vector store providers require you to create separate indexes for them. We saw that Quadrant had a better approach there. So that was another reason why when we were looking at implementing hybrid search, we were keen to kind of stick with Quadrant versus looking at other providers as well. But we're definitely building up a larger partner ecosystem as well. So we have partnerships with different vector databases. So regardless of what vector database you're using, Carbon can definitely support and stream the data directly to your provider of choice.
And since you're a provider, and also like a solution in the space, and you're using the different tools, what are like the configurations, the hacks, the tricks you have learned in using vector databases that you would recommend people using?
I think if you are cost conscious and if you're worried about performance, I would definitely look at quantizing your embeddings. I think we've probably been able to, I don't have like the exact numbers here, but I think we might be saving at least half in storage costs by quantizing everything. It does provide a slightly less accurate results, very slightly, like marginally, but the benefits you get on the cost side are truly unbeatable. So that's something I would definitely look at. There's also now we're seeing embedding models continue to improve, and OpenAI, I believe Cohere, they also launched models that have smaller dimensions, which also means that there's kind of less to store. So that's something I would maybe push listeners to think about as well. Do you need a embedding model that has 1536 dimensions, or can you get away with one that has around 700 dimensions? Especially if kind of from the benchmarks, the improvement in like accuracy is negligible, or maybe by like 1 or 2 points. So that's definitely a trade-off I would consider, and it also kind of depends on the scale of the content that you're trying to index and run retrieval on.
Yeah, and I think the with Matryoshka embeddings as well, you have so much basically of space to explore, and I think like embedding models are one of the areas in comparison to LLMs that's still very underexplored, and especially I rarely hear someone actually fine tuning an embedding model for their use case.
Totally, for sure, for sure. I think one hot take I have, people are kind of trying to optimize around the chunking strategy, and should I be chunking with a JSON representation or with a markdown representation or plain text, right? I see a lot of discussion there. But for me, like that seems a bit maybe not focusing on the right area of optimization. These embedding models themselves have gotten just like so much more advanced over the past 5 to 10 years that regardless of what representation you're passing in, they do a pretty good job of being able to understand that information semantically and returning the relevant chunks. So I definitely would love to maybe see a bit more attention shift to like, hey, like how do we continue to kind of drive innovation on the embedding model so that in the next 5 years, next 10 years, we're still seeing these leap in advancements that we have in these embedding models that we have seen in the past 10. And I think the juice is probably more worth the squeeze there than figuring out like different ways of chunking the document that gets embedded.
Yeah, and I think like everyone is now obsessing like long context window, rag is stat. They're obsessing about that. I think it's still worth obsessing, like feeding in the best possible context into the model, and you're likely to get something good out of it.
For sure, for sure. I think like, in this multimodal world that is emerging with videos, images, audio all being kind of ingested and passed into this context window of these LLM models and it being able to understand all these different modalities, I think there definitely is a spot for RAG within that paradigm as well. Something that we really, really want to see is a vector database that does well with multimodality and embedding models that do well with all this multimodal data, right?
Yeah.
Right now, we still are using different models for each, which means you can't really search across them all in a truly uniform manner. We do have one API endpoint that allows you to search across all of your audio, video, text content, but we're not able to actually imbue the semantic meaning between different file formats still. So that's something I really, really want to see. I would say that, Google is definitely kind of making advancements there with their multimodal models, but I still wouldn't kind of use their multimodal model for text, right? Because I think OpenAI's models and Cohere's text embedding models definitely kind of outrank the multimodal embedding model that Google has out there.
Yeah, I think I'm really excited for what OpenAI will actually bring out once GPT-4o actually really launches to public,
Yeah.
because they have been the master of embedding models the whole time.
Yeah, for sure. For sure. So yeah, I could definitely see them coming to market with a multimodal embedding model first, just given kind of what we've seen around the capabilities of 4.0.
Yeah. What would you say is actually missing from the space?
I think it would be kind of what we were kind of discussing already, like a truly multimodal model that is really, really good at text and audiovisual, and also a vector database that could handle all these modalities. I do see that there are some startups that are working on multimodal vector storage, definitely keeping a tab on all of those. But with Pinecone, with Quadrant, with Milvus, Weaviate, the larger players, I don't know if that has been a large enough area of focus that I think it should be. The other thing that I think is interesting is behavioral embeddings, right? Like, how do you represent human behavior as embeddings? And that actually might give a models an edge in understanding our behavior. So that's kind of an area I know that a lot of self-driving car companies are researching. But then I wonder what the application of that is to the broader mainstream consumer market and applications of generative AI.
Yeah, that's actually really close to recommendation systems like building user profiles, building customer profiles. Really curious about that as well. That space will be moving, especially as we capture more of the interaction data of actually users.
Yeah, totally. So like for self-driving companies, they need to know like, hey, like based upon my understanding of human behavior, like am I gonna, as a human, walk in front of that car and should that car brake? Or am I going to, based upon their interpretation of my body language, of my reaction, like am I gonna stop instead, right? And can they continue to drive? I think that has applications for these humanoid robots that we're now seeing, right, from Figure and others, right? How do you kind of, distill down all of kind of human behavior from our facial expressions to our gait, right, as we walk and our gestures, right? And then how do you kind of embed that in a way that these robots can then draw upon this wealth of knowledge around our behavior and use that to kind of inform how they interact with us moving forward.
Yeah. And I'm really curious, in your docs, you also mentioned that Carbon auto scales. What is like the underlying infrastructure tech stack that you can highlight that you're using?
AWS, we're an AWS shop. Honestly, like pick your poison, whether it's AWS, GCP, Azure. I think they just do a really good job of providing you with a bunch of building blocks for these highly scalable services that you'll be able to build on top of them. So we are leveraging that to the maximalist extent. The AWS stack to enable auto scaling and to be as high availability and reliability as we can be.
Yeah. Are you doing serverless or more Kubernetes?
We're doing serverless right now. I think Kubernetes is kind of definitely on our radar, just given that we are starting to support more on-prem deployment of Carbon as well. And Kubernetes, I think, is by far the easiest way of deploying into someone else's virtual private cloud. But for now, like we've been, getting by using Terraform, being more serverless in our approach. But I'd say Kubernetes is definitely the direction we are taking Carbon on the architecture side this year.
Yeah. I'm actually always curious from people who are working in this space. What are like some libraries, tools, services that really stick out to you, especially like beyond vector databases and the more common tools?
For our OCR, we have been using TextRack, AWS TextRack, and we tested out like a lot of different like OCR libraries, and TextRack by far performs the best. And we were shocked, right? Because like a lot of these companies, they're using LLMs to do the parsing of the PDF, especially ones that have a lot of images, charts, and tables. But honestly, like from all of the testing we've done, this AWS solutions still provided the best results, which definitely surprised even us. That's one. Honestly, the power of SQS, like simple queue services that AWS has, truly is amazing. We have async architecture, so we rely really heavily on queues. And they just make it super easy to spin up queues for different customers, different data sources, etc. So can't live without that. And then CloudWatch is another AWS service that I think we cannot live without, just given that we have very high daily usage. It's really our customers' users that are using Carbon. So if our customers has millions of users, those are the actual kind of people that are using our solution. So that means that our customers might not have the visibility that their end users have into any kind of bugs and issues with Carbon, because they're not the ones that are using it. They just implement it for their users to use, right? So for us to be really proactive about logging, alerting, monitoring to make sure like if any kind of bugs that do come up or any issues that do come up, we're the first ones to catch it before our users notify our customers who notify us. That's something we really kind of take pride in. That's sort of proactive response to triaging and addressing issues.
Yeah. And what's next for you? What's next for Carbon? What is on the horizon that you already can teaser?
I think our goal is to be more of a platform. We really want to build out this ecosystem. So, we have our source connectors. So, that's the Google Drive, that's the Gmail, that's the Slack that we talked about. We are adding more embedding models. So, right now we have Cohere, OpenAI, we have Upstage, and we're adding a few others as well, both managed and open source. And then we're constantly building out our catalog of destination connectors as well. So being able to stream to Pinecone, Quadrant, Supabase if you're using pgvector. So that is how we kind of envision ourselves really becoming a connector between the different pieces that are needed to build out your RAG pipeline. And I think kind of longer term, it is interesting if we can really build out this truly all-in-one solution where they could come to Carbon, they could pick out, again, the pieces of Carbon that they want to use, and then they could use these pieces to really kind of build out an end-to-end RAG pipeline out of the box.
Yeah. And if people want to start building the stuff we talked about, where would you point them?
Yeah, so we actually just launched self-service. So if you go to portal.carbon.ai, we haven't publicly announced this yet. So this is the first time on this call that I'm sharing this. But if you go to portal.carbon.ai, you'll be able to sign up, get an API key, and we give all of our users 1 million characters for free that they could use. And then after that, they're off to the races. They could start connecting as many data sources as they want, syncing PDFs, websites, etc., and get started with their RAG journey today.
Nice. And if people want to catch up with you or follow along in your journey, where would you point them?
Shoot me an email, Derek@carbon.ai. And yeah, always happy to chat and talk shop.